Hey guys, welcome to another tutorial. In this tutorial we'll be learning how to use data structures to create a 2D terrain world. It's going to be the most lag-free terrain you'll be able to create. It's also going to have an active lighting system. So this is how the game looks. As you can see, to the left and right of the screen, there are chunks being loaded and unloaded. Each chunk has a surface of all the tiles, and this surface is updated with the light effect. So let's get right into it. First things first is creating a room. This is going to have a width and height of 1, a room speed of 60. We're going to enable the use of views and have this to our preferred resolution. We're going to create an object called obj world. This is going to create everything. Then we also want obj camera and obj player. In our room, let's put down obj world and set it to the 0, 0 coordinate. So with our instance create of obj player, let's create the camera. And with the camera, under the step event, say view xView is equal to obj player.x and view yView is equal to obj player.y. This needs to be take the half the width, take half the height. So let's add a couple of sprites. I've already made some. So we're going to have the blocks. The first block is invisible, air. Then it's going to be followed by a value of 1, 2, and 3, which is a rock, dirt, and dirt with grass. And we're also going to create a quick sprite for the player. And center that. Okay. So now with our world object, we want to create a chunk loading and unloading system. So first, the tile size is equal to 32. The amount of chunks we want in our game is chunk amount x. So we want 50 chunks. And how many tiles in that chunk? So we want chunk amount tile x. 10 tiles in each chunk. This will be later refined. We also want to load x and y positions. Then we want the loading distance, which is 1 distance away from the player. And we want an unload distance of 1 on top of the load distance. So the chunks are unloaded that far away. And then we also want a reload distance, a distance around the cursor we want to update. And we want a shadow distance of 5 blocks. And we want to create our grid. So the first grid is the world grid, which is going to have the value of every single tile in the game. So our world grid is equal to dsGrid create. It's going to have every tile. So the amount of chunks, which is chunk amount x, and the amount of tiles in that chunk. So chunk amount tile x. And we do this for the y as well. Chunk amount y times chunk amount tile y. And we're also going to have script generate world. So this is going to create our world of tiles. Let's just put in a filler there. So script generate world. And let's just say, let's fill the whole grid with 1 values so we can see it. So world grid with the value of 1. Then we also want a grid for all the surfaces of our chunk. So this is going to only be a chunk size. So it's going to be surface grid. It's equal to dsGrid create. The size of our surface is a chunk. So chunk amount x and chunk amount y. So this is what we're going to need for our grids. So under our draw event, so what we're going to do is we're going to load in and out the chunks and the surface that they've created of the tiles. So let's find the chunk that the player's in. So the load x position is equal to the obj player.x. And we're going to divide this by how many tiles there are in a chunk. So chunk amount tile x and times this by the size of our tile. And we do this for the y as well. Load x, since we're going to be doing a range of grids, we want this to be inside our bounds, so it's equal to the clamp of feeding itself. So load x, its minimum is going to be subtracting the load distance, so we don't want that to go below 0, and its maximum is the amount of chunks. So this chunk amount x, take the load distance. We're going to do this for the y as well. So this is in our bounds. And now we also want to add on top of that our unloading distance. So we're going to be creating 4 variables for all the directions. So if our unload left is equal to the greatest value of load x take unload distance with a value of 0, and var unload right is equal to the smallest value of load x plus unload distance with the amount of chunks, which is chunk amount x. And we're going to do this for the vertical, so var unload up is equal to the greatest value of load y, take unload distance, 0. Var unload down is equal to the smallest value of load y plus unload distance, and the amount in the line. Okay, so now we've specified how much of the chunks we want to load and unload. Let's go through a for loop for the specified region of chunks, and basically say if they're in the loading region, then have a surface create for all the tiles. Outside of our range, then we'll free that surface. So for the chunk we're loading, chunk load x is equal to unload left, and chunk load x is less than or equal to unload right, chunk load x plus equals 1. And we do this for the y direction as well. So for the chunk loading of y is equal to the unload up, and chunk load y is less than or equal to unload down, chunk load y plus equals 1. So for all the chunks in the region, we want to find out if they're in the loading region. So the loading region is if chunk load x is greater than or equal to load x take load distance, or chunk load x is just less than the load x position plus load distance. So it's in the bounds of the x coordinate that we're able to load and create the surfaces for, and or the vertical, so chunk load y is greater or equal to the loading position y, take load distance, or chunk load y less than load y plus load distance. Okay, so this is everything that we're going to be drawing and showing. Otherwise, if it has been created, then we delete it because it's in the unload distance. So if it's in the loading distance, we want to check if a surface exists already. So we check our surface grid. So if our surface is equal to ds grid get our surface grid with the chunk load x and the chunk load y. If surface doesn't exist, then let's create it. So to create the surface, we're going to have to go surface is equal to surface create, the amount of tiles, which is chunk amount tile x times the tile size. And we do this for the y, so chunk amount tile y times tile size. And we say surface set target for that surface, and we're going to iterate between all of our tiles and have them drawn. So we go for var tile x is equal to 0, tile x is less than chunk amount of tiles, tile x plus equals 1, and we do this for the y as well. So for the tile y is equal to 0. Tile y is less than chunk amount tile y. Tile y plus equals 1. So the tile, we want to read from our world grid what this tile is. So we go var grid tile x is equal to its value in regards to the grid, which is going to be the chunk position, which is chunk load x, times the amount of tiles in a grid plus the tile position. So we do this for the y as well. So the grid position is the chunk load y times the chunk amount of tiles plus its tile position. So var tile is equal to ds grid get our world grid with the grid tile positions, and we say if the tile is greater than 0, so there is a tile there, we go draw sprite ext and we draw the block. So SBL block, its subimage is its tile, and its x and y coordinate is equal to tile x times the size of a tile and tile y times the size of a tile, and its image x and y scale is equal to tile size divided by 32, tile size divided by 32. Its rotation is 0, its image blend is C white and has alpha 1. And after drawing the surface, let's go surface reset target, and let's set this surface to our grid. So ds grid set our surface grid, the chunk load x position and chunk load y position to be equal to surface. And now since we've already pulled that, if surface exists, surface, just to be sure, then let's draw the surface, which is either pulled by the grid or created in this event. And since it's in the position that we're seeing, we're going to draw it. So draw surface in the chunk load x position, chunk load y position, which is going to times by the amount of tiles in a chunk amount tile x times the size of a tile, which is the tile size. And we do this for the y, so chunk load y times the amount of tiles in a vertical chunk and times by the tile size. So if it's in the loading distance, then it's going to create the surface and draw it. But if it's unloading, we check our surface value again. So surface equals ds grid get the surface grid of our chunk load x and our chunk load y. If the surface exists for our surface, then we want to go surface free surface, and we want to say ds grid set our surface grid in our chunk load and y positions to be -1 again. So in our create event, we want to make sure that this is by default -1, so ds grid clear our surface grid with -1 values. This is because it's remembering what the old surface was. So whenever we create a new one, we've got to remember to draw clear. So you want to specify the width of the entire game. So game width is equal to the number of chunks times by how many tiles in a chunk times by the size of a tile, and the game height is equal to the amount of chunks times the number of tiles times the tile size. And basically we want to put the player into the very middle of the game. So instance create game width over 2 game height over 5 obj player. So let's have it so we're able to delete a tile. So with our obj world, under our step event, if mouse check button press for the mouse button left, we want to update our world grid to remove the block, and then we want to update the surfaces that are neighboring. So let's find our position relative in tiles. So our mouse grid x is equal to mouse x div tile size, and our mouse grid y is equal to mouse y div tile size. And we say for our world grid position, ds grid set world grid, in our grid position of the mouse coordinates are going to be set to 0, an empty spot. Now we got to update the neighboring surfaces to incorporate the change in shadows. So we got to find its chunk position, which is mouse chunk x is equal to mouse x div the amount of tiles, which is chunk amount tile x times the tile size, and mouse y position is equal to mouse y the amount of tiles times the tile size. So now we know what chunk it's in, and we want to reload the surfaces around that chunk as well, because we're going to be affecting the light. But reload left to be equal to mouse chunk x with the maximum value of take reload distance with 0, and we want reload right to be equal to the min value of chunk x plus the reload distance with the amount of tiles, so chunk amount x, and we want reload up to be equal to the maximum value of chunk y, take reload distance, and we want down reload distance to be the mouse chunk y plus reload distance plus the number of chunks. So it's in our bounds of our grid. So now we want to iterate for all these. So var chunk reload x to be equal to reload left, while chunk reload x is less than or equal to reload right, chunk reload x plus equals 1. And we want to do the region for the y as well. So this region we want to be reloading for when we destroy a block. Reload down. So for the region of reloading, you want to check if a surface exists. The surface is equal to ds grid get the surface grid with a position of chunk reload x and chunk reload y. If the surface exists, surface, then we want to delete it, surface free, and we want to mark for deletion, so set this value, reload x and chunk reload y to be -1. So let's add our lighting system. So you draw a vent for that individual tile if it exists. So what we do is we find the nearest position in our grid that is empty with an increasing radius, and then we use that radius to score how dark that object becomes. We want to establish radius to be equal to 0, the distance that is achieved to be 1, and we've already established a variable called shadow distance to remember how far we're able to go. So while radius is less than or equal to our shadow distance, then we're using the if ds grid value disk exists function. So it's checking a disk shape, like a circular shape of our grid, to see if it has a block value of 0. So we go world grid with the tiles position in the grid, which is grid tile x and grid tile y, with the radius, and if it has a value of 0. If this returns true, then we want to stop it, so the distance is equal to the radius is found, and the radius is going to end the while loop, so the radius is equal to the shadow distance plus 1. Otherwise, we just want to increase the radius until it's found, and the distance is equal to radius. Now based upon this score, you want to merge a color from C white to C black with a score value of distance we've accomplished, take 1 divided by the shadow distance. Now we want the player to be able to move around and interact with our grid. Create a new script. This one's going to be called script grid meeting, and we're going to be finding the nearest place meeting coordinate of our grid and return a collision. So the fed values are the script grid meeting. The arguments are the x and y coordinate that we want to use for a collision check. And we're going to be using var width is equal to 16, height is 16. Var the x previous position is equal to x, var y previous position is equal to y. Let's move to the testing position, which is the arguments. So x is equal to argument 0 and y is equal to argument 1. Basically what we want to check for is the top left, top right, bottom left and bottom right boundaries of our player. So to check that, we go player left is equal to the x take the width divided by obj world's tile size. So we're comparing it to the grid position, and var player right is equal to x plus width div obj world tile size. Top is equal to y take height brackets divided by obj world tile size, and the bottom is equal to this plus the height div obj world tile size. And basically we want to say if the two top positions are meeting a grid or the two bottom positions are meeting a grid. So we go top meeting is equal to the world's grid with the position on the top right corner of our player, and if this grid coordinate has a value greater than 0, or the obj world grid with the top left position has a value greater than 0. So there is a top meeting. Otherwise, for the bottom meeting is equal to the world grid position for player right with the player bottom is greater than 0, or obj world for the player left bottom position is greater than 0. If either of these are true, then we go return top meeting or bottom meeting, and we also want to come back to our starting position. So x is equal to x previous and y is equal to y previous. So now with our player, under our create event, let's establish our collision variables. So the horizontal speed is 0 and the vertical speed is 0. We want our horizontal speed to be equal to the keyboard check vk right take keyboard check. So if the position is free in the script collision meeting of the x and y position that we're trying to move to, so x plus horizontal speed y, then the x plus equals the horizontal speed. Otherwise, repeat the absolute value of our horizontal speed, and we go var sine the horizontal speed is equal to sine horizontal speed, and we want to move in the direction we were moving until we reach a collision. So we want to go if not meeting in towards 1 pixel at a time a solid grid component, then x plus equals sine h speed. If it's detected a collision, the horizontal speed is equal to 0, and then it's going to repeat in the direction it was going before it hits a solid. And we want to copy and paste this for the vertical. So plus vertical speed, y plus equals vertical speed. Otherwise repeat in how much and at 1 pixel at a time to the sine position ahead until it collides with it. And so we say vertical speed plus equals 1. If there's a collision below, so script collision meeting, 1 below us, if the key is pressed to jump, VK up. Then if there is a grid collision below us, then we say v speed is equal to -12. This is actually grid meeting, sorry. So if grid meeting, let's change all those to grid meeting. So times 3 times as quick. So let's make this a lot nicer. Let's create a background. I've got one handy, which is background sky. This is my sky background, and I've stretched it to my resolution. I'm going to create an object called obj background. In the create event, I say background index is equal to back sky, and I say background visible is equal to 1. Under the step event, I say background x is equal to the view x view, and background y is equal to view y view, and background x scale is equal to the view width divided by background width, and background y scale is equal to h view divided by background height. When we add this to our room, it's going to draw a background around our view. And when we generate our world, we basically create a brush that's going to iterate through horizontally all the tiles and then come up with a random vertical difference and fill that entire space with air. And then the top block is going to be turned into grass, and a random amount downwards is going to be dirt. So we go var air x is 0, var air y is 0, var air y min is 300 due to the tile size, var dirt y random is equal to 6 blocks below, and var dist y is equal to guaranteed 4. Alright, so while x is less than or equal to the amount of tiles, chunk amount x times chunk amount tile x, and we want air x to plus equals 1. We want the y to be completely random, so air y. We also want to implement a y change value, so air y plus equals air change, and air change can be a value between -2 and 2, and air y is being clamped to value of the air y min, and the game height is over 5 with itself. And so we set the region above the land to be air, so ds grid set region of our world grid for the position of air x 0, air x, and air y to be a value of 0. So everything above this point is air. And then you want to ds grid set that position of air x and air y to be a value of grass, which is 2. And we want to set everything below to a random amount to be dirt. So world grid air x y plus 1 x y plus 1 plus dist y plus I random dist y random to be 2. In our create event, we want our game width and height to be created before the world grid. So let's have a look how our game generates now. So this is how the game looks. As you can see, to the left and right of the screen, there are chunks being loaded and unloaded. Each chunk has a surface of all the tiles, and this surface is updated with the light effect. When you destroy a block, it tells all the surfaces to be updated that are close to that position. Under our generation script, we've generated a simple world for the top. If you were to limit your view to be within the bounds of the loading and unloading, this game would appear seamless. Any latency is at your control, as you can specify how many tiles there are in a chunk, how many chunks there are, and the distance to draw the shadow. Hope to help you out a lot, and thanks for watching. Catch you next time.